Okay, so today in 8.5a and also in 8.5b, we're going to look at solving exponential and logarithmic equations. In part A, we're going to strictly stick with exponentials, and then in part B, we'll look at logarithms. Now, you will need your calculators today. The stuff that we do, with maybe one or two exceptions today, are things that I would let you use your calculator on in terms of tests or quizzes or that kind of thing. So you will need your calculator. Okay, so I've given you a couple of examples here. What we're doing is we're solving for x. So if your bases are not equal, and you'll see my base here is 3, my base here is 0.2, most of the time they're not going to be equal. If your bases are not equal, then you want to go through and take the log, meaning log base 10, right here in my calculator, or the natural log, also in my calculator, of both sides of the equal sign. Now, it doesn't really matter which one of these you do. It's your choice, but you want to make sure you use one of these because these are the two types of logarithms you can do in your calculator. So take your pick. It doesn't really matter, but make sure you use one of those. So I'm just going to go through and take the log of both sides. Now let me write out what I have. You can probably do this one step less than I'm doing. Now, here's the point of doing this. I want y'all to think back to 8.4 and the product rule, not the product rule, the power rule. Remember how the power rule says that if you've got an exponent, you can pull it to the front? That's what I'm going to do. I'm going to use that power rule and move my x to the front. Now, look at what I have here. I've got something that I can solve. I can divide by log of 3 and get that x by itself. So my x is whatever log of 0.2 divided by log of 3 is. So I'm going to put that in my calculator and see what it turns out to be. So log of 0.2 divided by log of 3. Now here's my answer. I'm just going to round to 2 decimal places, so negative 1.46. So that's what my x value is. Now do y'all see how you will need your calculator? This isn't something there's going to be one exception here in a minute. With the exception of one or two things, you're going to need your calculator. Okay, so I'm going to go through, kind of do the same thing here. I'm going to take the log of both sides, which will allow me to pull this to the front. So I've got x minus 3 equals log of 5. I'm sorry, x minus 3 log of 5 equals log of 137. And then I'm going to solve for my x. So I'll divide by the log of 5. Now for me, I like to put this all in my calculator at once. So I'm going to go ahead and finish all of my computation, then I'll put it in the calculator. And then I'll add my 3. All right, so what I want to do in my calculator is log of 137 divided by log of 5, whatever that is, plus 3. Okay, so I can do that. Let me clear this out. Log of 137 divided by log of 5, and then add 3. So 6.06. Okay, now I just want to specify something. If you have anything that has an e in it, a base of e, use natural log instead of using log base 10. It's still one that you can do on your calculator. It'll just save you a step because things will simplify a little bit more. So if you've got an e in your problem, use natural log, not log base 10. Now I'm going to show you why in a problem. Alright, so I'm going to use natural log instead of base 10. I'm going to write out what I have here. Now if you're doing it on your own, I think you can do this step right here. Now here's what I want you to see. If you think back to our shortcuts, remember how natural log is base e? See how those match up, which means I'm just left with my x. The shortcut said if those simplify out, you'll end up with just the x. It's like you could pull it to the front. Natural log of 0.83. So if I put that in my calculator, I know what my answer is. So let me clear that out. Natural log of, what was the number again? 0.83. So negative 0.19. So if you've got an e in your problem, use natural log. Okay, now this is true. I'm having an e here, but you could have some other base. If you've got other stuff in your problem, go ahead and move that over. Get your base to the power by itself. So I'm going to take one extra step here. So I'll have e to the 2x equals 64/5. And then remember, use natural log. You'll be glad that you did. Now that's going to make these guys cancel and leave me with the 2x equals natural log of 64/5 divided by 2. And then I'm running out of space, so I'm going to put it here, but I'll put all of that in my calculator. So I'll have natural log of 64/5 and all of that divided by 2. So 1.27. Okay, now I want us to do 2 more practice problems before, oops, I went too far, before we kind of stop. Now this one doesn't have a base e, it's got a base 7, so it doesn't matter if you use natural log or log base 10. I'm just going to use log base 10. I'm going to take the log of both sides, which will allow me to pull this to the front. So I have 2x plus 1 log of 7 equals log of 3. Okay, so I'm going to divide by the log of 7. Now I want you to notice these are 2 separate logs here, a log on the top, log on the bottom. It's not the same as log of 3/7. It just doesn't work that way, so make sure you have log both places. Now I'm going to subtract 1 and divide by 2. That'll give me my x value. Okay, now I have this written down. I better look at it as I'm putting it in my calculator. All right, so I have log of 3 divided by log of 7 minus 1 divided by 2. So negative 0.22. Now you'll notice you'll get messy answers on here. Now this is the last problem. This next one is the last problem I want us to look at. Now I want us to look at this one because you'll notice that we've got 2 e's in this problem, 2 bases, not just one. What I want to go through and do, and y'all go with me for a second, is I just want to rewrite this because I think we can factor it. It's just hard to look at it and factor it. So what I'm going to go through and do is I'm going to replace my e to the x's with some variable. I'm just going to use, I don't know, p for Pinson. I'm going to replace e to the x with p, which means right here I'll have p squared plus 4p minus 5. Now see how this looks like straight up factoring. I'm going to factor it. So plus 5 minus 1. Okay, look at that. Make sure you're okay with it. Now we've done this kind of problem before. We'll worry about the e to the x's in a minute. Then remember I set these equal to 0 and solve. Now I'm going to write this out. Now at some point you need to replace your e to the x's in for your p's. I'm going to pick this place right here. So I'll have e to the x plus 5 equals 0 and e to the x minus 1 equals 0. Then I can go through and solve. All right, now I want y'all to think about things we know about logarithms. Try not to use your calculator. Think, think, think. What's going to happen when I take the natural log, and I'm doing natural log because of the e, what is the natural log of -5? Now I'm hoping you're telling me no solution, because remember, you can't have a negative logarithm, a negative inside the logarithm. If I were to do natural log of -5, it's going to give me that error message. Remember, we had that error message before. So I have no answer right here. That's something I want you to know. If you've got a negative value right here, you can't do it. It no solutions out. Okay, I'm going to solve here. Move the 1 over. E to the x equals 1. Now I think we can do this one without our calculator. I want y'all to think shortcuts. So that cancels and leaves me with x equals natural log of 1. Okay, think shortcuts. What is the whole value if I've got a 1 inside my logarithm? Y'all think, y'all think. Remember, it's 0. Now, I don't think I still have that pulled up here, but it was one of the shortcuts. If I've got 1 right here inside the logarithm, the whole thing equals 0. So my only answer here then is 0. This one, no solution now. All right, now in 8.5b, we're going to look at solving logarithms. This is solving exponentials here in part A. All right, so we'll stop right there.